Hi everyone. In this video we are going to discuss the topic of electrolytes. An electrolyte is a substance that when dissolved in water dissociates into ions. And there is a spectrum here. We can have strong electrolytes, weak electrolytes, or non-electrolytes. And this criteria is based on whether or not the substance dissociates 100% into ions, or only partially into ions, or into no ions at all. So the first type that we are going to look at are strong electrolytes. These are, as I said, going to dissociate 100% of the compound into ions. And as we are already familiar with, ionic compounds, when mixed with water, dissociate 100% into the aqueous ions. So this abbreviation AQ after the symbol indicates that it's aqueous, that it's dissolved in water. The S here indicates solid. And we could put an L here for liquids. Okay? Another type of strong electrolytes are the strong acids. So something like HCl, which is a gas at room temperature, mixing it with water as a liquid, will produce H plus aqueous ions and Cl minus aqueous ions. So it is a molecular compound to start, but because it's a strong acid, it wants to lose that proton. It is stable losing that proton because Cl minus is especially stable. We see this happening 100% in solution. So these form ions at 100%. So this is a one-sided reaction arrow when these are mixed with water. Now, the other type of electrolytes, weak electrolytes, only dissociate partially. So an example of a weak electrolyte is a weak acid. This is acetic acid, CH3COOH, having a structural formula as that. When this is mixed with water, we get partial dissociation. So we get some of the anion, CH3COO minus aqueous, and H plus aqueous. And sometimes you may see this written as H3O plus rather than a lone proton here, because that proton is going to be attached to a water molecule. We're not going to get into the idiosyncrasies of acid-base reaction writing here, but just know that H3O plus is another way of writing H plus when it's in water. And another type of weak electrolyte is a weak base, like ammonia, which is a gas mixing with water. We have an equilibrium again established here. We get NH4. This will pick up a proton, as a base does, from water and generate some OH minus here as well. So the fact that this is equilibrium, meaning the forward reaction and the reverse reaction are happening at the same time, and there is always some of the entire molecular compound here and some ions present, and so this is less than 100% dissociation. And the percent dissociation is related to acid strength, so the stronger the acid, again we have a spectrum scale for acid strength, the stronger the acid, the more willing it is to lose that proton, so the more of the ions you would have in solution. And pH is a measure of ion concentration, so having more protons would decrease the pH rather. Okay? And then compounds that do not dissociate at all are called non-electrolytes, and these are electrolytes. These are are molecular compounds, something like sugar, C6H12O6, mixing in water will just produce some dissolved sugar, C6H12O6. Now we call this aqueous. We have not made any changes to the structure. The molecular integrity is preserved.